So, hey guys, welcome back to Codecules. My name is Harshit, and today is day 27 of our 45 days of code challenge, where we are solving Striver's A to Z sheet. And our goal is to solve all the full 445 days of problems in just 45 days. So, let's go. And today we will be solving recursion problems from very basic to advanced level. Following a patterns. So let's get started. Yesterday we had already solved some basic problems on recursion. Let's add these problems from the list drivers sheet into our checklist, and then we will move ahead. It is step number 7, which is recursion patternwise. Am I audible clearly? I think I was. Yes, I am. So the lecture one will cover basics of the question that we were doing. And mm, what are the 5 problems in the basics? Recursive implementation of ATY, that was converting string to integers, right? 32-bit integer. So the first problem is recursive implementation. Recursive implementation of ATOI. And the next problem is power of x comma n. And then the next problem is count root numbers. Solve a stack using recursion. Reverse a stack using recursion. And then we will try to solve the subsequence problem today itself. So let's get started. Sit back, relax, and enjoy the show. Go good, Getacho. So the first problem is generate all binary strings. Generate parentheses. Then print all subsequences. Double set. Learn all patterns of subsequences. Choose and then count all sequences with some care. some k. Check if there exists a subsequence with some k. Check if there exists a subsequence with some k. Combination sum, combination sum 2, and then subset sum 1 and 2, and then combination 1, 3, and then let a combination perform as well. So these are the problems that we are supposed to do today. And before we dive into that, let's revise what we were doing yesterday. We had solved these basic problems of recursions for revision. Let's revise again. What is recursion? Recursion is nothing but a method of solving a problem by calling a function inside itself to solve the smaller parts of the problem or the smaller instances of a problem. That means dividing the problem into smaller parts and then solving them. So best practices and intuition. Let me start. Let's quickly see the definition. A function that calls itself with a modified input until it reaches a stopping condition is called recursive function. Real world analogies, let's not get into that. Importance of recursion. Mm, okay, trees and graph uses recursion very much. Backtracking and divide and conquer problems uses recursion. Foundation for advanced algorithms like merge sort, quicksort, DFS, PFS. Essential for understanding data structures like binary search and linked list. Okay, critical for confident programming. All bull. Okay, so the very first and the easiest implementation of recursion is factorial of a number, where we recursively multiply the numbers by reducing by 1. And the base case for this is when n is equals to 0 or n is equals to 1. When n becomes 1 or 0, it returns 1, right? And then the Fibonacci numbers, where the next number is the sum of the last previous two numbers, while n is greater than 1. And if n is equals to 0, it returns 0. If n is equals to 1, it returns 1. So this is all about Fibonacci number that we have also created the program for it yesterday. So let's cover the basics first. So we open our VS Code and finish what we started. Let's say find max we had done already yesterday. Let's continue. Sum of n numbers was also done. Then types of recursion, direct and indirect recursion. Direct recursion when the function calls itself inside its body. And indirect recursion is something when another function calls the first function recursively. Okay, when two functions call each other recursively, it is called indirect recursion. Then tail and non-tail recursion. Uh, last operation. I too need to get a clear understanding of tail and non-tail recursion. Tail recursive call is the last operation in the function, and in non-tail recursion, operations are performed after the recursive call. Operations are the last. Okay. So tail recursion can be optimized by compilers to use constant stack space. That means we should. Okay. So the last operation is the recursive call. Recursive call is the last operation. And in non-tail function, we are multiplying after recursive call. Okay, I think I got it. Linear recursion, simple factorial. Tree recursion, the Fibonacci number when two recursive calls are added, and we can optimize this by some method. We have to optimize this because it is not optimal because it takes too much space. Solving the same problem repeatedly. And then nested recursion, recursive call with a recursive argument. Mm, okay, nested recursive call, mutual recursion, implementation details step by step, call stack growth. Let's trace factorial 4 execution. So when we call factorial of 4, the factorial 4 is called stack में factorial 4 insert हो जाता है. It is checked if 4 is less than equal to 1 or not. It is not. The execution will return 4 into factorial of 3. Now the factorial 3 will be called and the stack will contain factorial of 4 comma factorial of 3. Now we are discussing about factorial 3. It will check if 3 is less than 1 or not. It is not, so it will execute return 3 star factorial of 2. Then factorial of 2 will be inserted in the stack, and then it will calculate factorial of 2 and check if 2 is less than 1 or not. It is not, so it will return 2 star factorial of 1. And then factorial of 1 will be inserted in the stack at the top, and it will compare. Am I audible? So the factorial of 1 is less than or equal to 1, then it will return 1. And then the backtracking will be done. Factorial 1 returns 1, and the stack will remove the topmost factorial of 1, and it will be multiplied to 2, which will return 2, and which will be multiplied to factorial of 2. Okay, sorry, factorial of 2 will return 2, and which will be multiplied to 3, which returns 6, and factorial of 3 returns 6, which will be multiplied to factorial of 4. Factorial of 4, factorial of 3 will return 4, 4 into 6, which will return 24. And the factorial of 4 will return 24. Then the stack will become empty, and the final result will be 24. So the common mistake that the beginners make, missing base case बनाना भूल जाते हैं कभी कभी incorrect base बना देते हैं. बेस केस बनाना भूलना मतलब जैसे कि इनफाइनाइट रिकर्शन कॉल लगाना. There is no base case. And mistake number 2, incorrect base case. If n is equals to 1, return 1. Wrong. But what about n is equals to 0? So when we are recursively calling n minus 1, n will become 0 sometime, and we are not returning anything when n will become 0. And maybe n is given as 0, then also it will be problematic. Not moving towards Base case, okay. Forgetting to return recursive call result, okay. Modifying parameters incorrectly, okay. Mm, Return base into power of base common exponent of 1. Exponent minus 1. Exponent is the power to which we need to take base. If, if the exponent is 0, it will return 1. If exponent is 1, it will return base. Okay. Otherwise, base will be multiplied by base of. Okay, recursively, we are decreasing. Okay, it will return 1. 1 into base into base into base into base. Okay, optimized version. Uh, exponent is multiplied. GCD. I got it. I have not solved this permutation problem before. Mm, let's move to the problems that we were solving. Mm, we were on problem number 6, find maximum in an array. We had done this. Now we will do linear search using recursion. Let's create that. Continue these concepts in our day number 27 folder. Not here, but outside of all the folders. Underscore 27. And let's continue with, um, let's go to folder. Inside of problem number 7. That is, what is the problem? Linear search. Underscore 07 underscore linear search dot Java. So how do we search an element in an array using recursion? Let's create a new function SVN. Let's move this. Um, Here we are. So search for an element in an array using recursion. So let's create an array. Let's say int AR is equals to random numbers. Okay, and then let's say we create a function linear search public that put in linear search which takes int array and an integer k or target which we need to return and we will return the index of the target if it is found in our array. So what will be, let's say we are searching for 7. So we will do linear search of array comma 7. So this is what we need to do. And let's say what will be the base case if mm, we will create the variable in time is equals to AR out of lines. Mm, So we will also take n as the input that will be length of the array. We will check ourselves. So if n is less than equals to 0, return -1. Otherwise, if array of n minus 1 is equals to k, we will return n minus 1. If it is not the case, then we will call the function recursively to check for the remaining array. So we will return linear search in array k. We have to take the size of the array as input. Let's say int n, which will be given here as arr dot length, and then we will recursively call the linear search with n minus 1, reducing the size of the array. And then it will search in the remaining array. Let's run this function. So it is returning 8. That means it should be on the 8th index 0, 1, 2, 3, 4, 5, 6, 7, and 8. So it is correctly returning the index of 7 in the given array and it will work fine. Is my voice not clear? Problem number 8 is binary search. Binary search is also recursive. Let's create another file for binary search underscore 08 underscore binary search dot java psbi. Okay, psbn, and here we will use the method public static. क्या आंसर रिटर्न करना है इंडेक्स इंट बाइनरी सर्च इंट एरे इंट हाई इंट लो comma, and K is the key. Okay. So in the if I is less than low, if I get that. And then if low is greater than high, then we will return -1 and mid is equals to low plus high minus low by 2. High minus low by 2, yes. क्या बाद में करें. So we have created the node and we will then check if array of node is equals to a key, then we will return mid. Otherwise, if k is less than array of mid. Okay, one more thing, we need to make sure that the given array is sorted. So, okay, we will do that. Okay, if k is less than array of mid, then what we will do, if target is less than array of mid, we will update and return binary search of array, comma. We will update row, like the mid element is less than our mid element is greater than our target. That means our target lies in the left side, so we will update the right, that means high with mid -1. Okay, so the high will become mid -1, else we will return binary search of mid +1 comma high, and our target will be k itself. Mm, so we're just trying to present. Let's use an array graph of is equals to random numbers. Okay, and let's search for what should be searched for in this given array. Mm, binary search in the array. Low is 0, high is arr dot lamp -1, right? And our target should be, what should we search for? We should be searching for 75 or 55. Let's search for 55. Let's try to run it. It is returning 2. And if we search for 6, it is returning -1 because we are giving wrong length. It is returning -1 again. Low is less than high. Low is greater than high. Okay, it should be sorted. I told you already. 1, 2, 3, 4, 5, 6, 7, 9. Now, if we search anything, it will give the correct output. If we search for, where is it? If we search for 9, ये क्या हुआ? If we search for 9, why this is not working? Okay, by mistake I pressed numlock. Now it should work. Okay, so if we search for 9, it should return something correctly. It is returning another one because there is no 9. So, okay, it is working fine. Binary search is also done. Revised. Not even enhanced. Not where but in the game, but in the 7% And problem number 8, let's revise underscore 08 underscore. What is the eighth problem? Eighth one was binary search. Now it's 9. It is 9. 9, just check palindrome, right? Check palindromes or Java. So how do we check palindrome using recursion? String is a palindrome using recursion. Union. Okay. Let's say string s is equals to Madam and string b is equals to bullshit, and then we will apply check is palindrome like public static boolean is palindrome. palindrome is palindrome and will give string F as input and starting index and the ending index, right? So int start, comma int and that is fifth. Inside this method, we need to find, check if it is palindrome recursively. So, so what will be the base case for this problem? So the base case is empty string or single character. So if s is equals to empty string, then we will return will return true. Okay, not true, but return. Okay, so then if chart is greater than equal to and return true. Else if s return false. Okay. If s dot character at start is not equals to s dot character at end, if the outermost characters are not same, then we will return false. Otherwise, we will check for the reduced string. Is palindrome start plus one, start plus one, and minus one. That means we will increase the first pointer and decrease the last pointer. And this way, I think it should correctly return if the given string is true or false. Let's call it, how do we call it? SOUT is palindrome s start is 0 and is s dot length. Okay. And then SOUT is palindrome b start is 0 and is b dot length. And then it should work fine. Let's try to run this program. There's a problem. What we did wrong. Index out of bound for line 5. So starting from 0, we should be given length minus 1. True and false. So it is working fine. Again, reverse a string. Let's create another program. Underscore 10 underscore reverse string or Java using recursion, right? And here's VM. We have a string h is equals to Harshit. String I is equals to Hacker. And then we will call recursive function to reverse the string. Let's say public static public static uh, string, right? Public static string reverse, which will take string s, comma int start, comma int and and we will reverse it. We don't need start alone. We only need this. And the base case will become if the string length is less than 1. If s dot length is less than equals to 1, we will return s. Otherwise, we will return s dot substring from s dot length minus 1 and plus reverse of s dot substring, comma 0, comma s dot length minus 1. Will it work? Here should be character at s dot character at s dot length minus 1. Okay. Let's try to run it. So you see reverse I and so you do reverse H and let's run it. So it is working correctly. भागोड़ को रिवर्स कर दिया उसने. Generate subsequence. Let's move to the next problem. Problem number 11 for recursion basics. Underscore 1 underscore what is generate subsequence? Generate subsequence dot Java. So for each character, include it or exclude it. Use backtracking approach. Base case processed all characters. What is a subsequence, by the way? Mm, is it visible, right? It is visible, right? Okay, so a subsequence is a sequence derived from another sequence like array or string by deleting zero or more elements without changing the order of the remaining elements. So if a string is a subsequence is a new sequence formed by selecting some or none elements of S, keeping the relative order the same. So, okay, order matters. The relative order of elements in the subsequence must match the original sequence, not necessarily contiguous. The elements of a sequence don't have to be next to each other. Empty sequence is a valid and empty sequence is considered as valid subsequence. Okay, we need to generate all the sub arrays, right? 1, 2, 1, 3. Okay, all the sub arrays. Elements must be contiguous. In subarray, elements must be contiguous, but in subsequence, elements can be non-contiguous. Just maintain order. 1, 3 is not a subarray, but it is a subsequence. Okay, I got it. LCS, longest common subsequence, generating all possible subsequences, solving subset sum or combinatorial. So, how do I approach it? Pseudocode says function subsequence s dot index s comma index dot current. If index is equals to s dot length, print current. What is current? For each character, include it or exclude it. Step by step solution. Given an string S, generate all possible subsequences of S, and all the possible subsequences are empty string ABC, AB, AC, BC, ABC. So include, exclude the character. The include the character in the subsequence, exclude. Okay, in each character in the string, we have two choices. So this naturally forms a binary decision tree where recursion handles perfectly. Okay, this is for the first time we are talking about binary decision tree. So start with empty subsequence. Consider first character A, include subsequence become this, exclude subsequence will remain empty. Move to next character B. If we include it will become AB. If we exclude it will become A. Okay, so it will keep generating the tree. So recursion approach. str is the input string, index is the current position in string, and current subsequence being built. Result list to store all the subsequences. So what it is doing, the base case is index will become str.length. There is a list for storing the result. String current that is empty. Index. Okay, so we will give empty string as an input and 0 as the index and the result and the given string. Then, okay, let's try run. So what we actually have to do in the problem. Let's say given string S is equals to ABC. And then we need to generate all the subsequences. With that, let's create a method public static. It should return. So we will store the result in list. So we will check if index is equals to s dot one. If yes, we will print current here and go. Otherwise, subsequences and on current index will be increased by one. So in this case, we are excluding the next element, doing nothing. And in this case, we are including the next one. What was that one? And in this case, we are adding as dot character at index. Okay. And then it will run fine. And we don't need to store it as well. And we will subsequences of s connect index one and to string. Okay, let's run it. C B B C A A C A B A B C. Subsequences. Let's now move to the next problem. Generate power set. Generate all the subset of an array. All the subsets of an array. So the power set is the set of all the subset of an array. Okay. Let's create the function here itself. Public static void power set, and it will take input as int array whereof int index and int. It is not correct. Okay, what should I take as input for current? Current we will be printing, that will be the subset, that should be an array. Okay, current. Then we will do if index is equals to array dot length, then we will return or print current dot to strings. Okay, we will print the current array as strings. Okay, and then return. So it is our base case, and then recursively call power set of array and index plus one, and we will exclude the current subset. Power set of array comma index plus 1, and this time we want to add. Okay, so we will give the current array of size as of the main array. Okay, and then we will mm, current at index will be equals to ARR at index. Okay, I think I'm getting it right. What it is, it should be returned as a string. Oh, array. Oh, okay, let's make the result as a arrow list. And subsequent वाला part ठीक है. So we will take the result as array list. Array list. Where are we? Okay. And current dot toString will work or not. Instead, we will directly return current and it will print it. And then in this, we will return current dot add ARR on index. Okay. Brilliant. Where? It's, why Boolean, bro? ये वाला पार्ट तो समझ में आया. Use list to store the current subset, but how to return it? How to update the current subset? Okay, we have to do it individually. यहीं पे बना हुआ है पूरा. ठीक है. We will update the current as current. Okay, and then we will return current. Now it is right. Okay. So how do is it good to go? Let's try to run into new program. Control X. Let's create a new file for this underscore 13 underscore power set dot java and PSVM. And in this, we have this method, and then we have an array, and we need to generate its power sets. So int arr is equals to, let's say, 1, 2, 3, 4, 5. Let's say 1, 2, 3. Okay. And we want to generate power set of array from index 0, and current is array list current. Array list integer result is equals to new array list. And we will give current as result initially, which is empty. Now let's try to, okay, power set, we have called it already, and let's run it. It is working fine. But we have to backtrack as well. That means after calling this method, we need to remove. Now if you run, there is an error. What is the error? Index 3 out of bound for length 1. What's the error? Hmm. No, it is working fine. And it's to go. And let me take a break. Hey guys, I'm back already. So let's get back to the problem. So let's get back to the problem. So let's Okay, so the next problem is count subsets with sum, given sum. How can we do that? Include only if remaining sum allows. So, okay, it is similar like the power set problem. Underscore 13 underscore count subset with some Java. And we will create, okay, first the driver code from SVM, and then we will create public static uh, in count subset of array and index and sum and sum, right? ये तो डीपी का प्रॉब्लम है. So recursion is the brute force approach, and DP and optimized DP are the best solution for this. So let's see the recursive approach. The problem is to count the number of subset of a given array such that sum of elements. Okay. Count of subsets with sum equal to target using recursion. ठीक है, we consider two cases for recursion. Exclude of current element. The current element is not included in the subset and the sum remains unchanged. So this is the condition that we need to keep in mind. So so in this case we have sum instead of the result, and we will check if index is equal to array dot line. Good. And sum, not sum unit count. So what we have to do, in the base case, we will check if the index is equal to the length of the given array, and if the remaining sum is 0, it is a valid subset and it return 1. So if sum is equals to 0, we will return 1. And we will be recursively subtracting the current element from the array. Okay, array index plus 1, and sum will be same as we are excluding, and option 2 will be include count subset of array index plus 1 and sum minus array of element of array index. And we will return include and exclude. What is the error? We have not printed anything. Yes, so you please, and here we go. Let's run it. Okay. So it is returning 3. So is it right? Uh, Number of subsets. So one subset is 3 comma 3, another subset is 1 2 3, and another subset is, okay, 3 and 3 will be counted differently. It is right. Let's take this example as well. Let's move to the next problem now. So we have done this count subset with sum, and now we will do string permutation using recursion. Let's create a new file for it. Underscore G14 underscore string permutation dot Java, and let's go PSBM. So what are the permutation? Fix each character at first position, generate permutation of remaining character, use swapping for backtracking. So we need to return the all possible arrangements of its characters. Understand the pattern. Permutation involves arranging elements in all possible orders. For a string of length n, there are n factorial permutations. So we need to fix one character at a time and recursively permute the remaining characters. So the base case for recursion logic will be if the string has only one character left, so suppose ABC is the given string, fix A and remaining BC will be permute BC and CB. You just need to swap. Recursion plus backtracking problem. Backtracking ensures we restore the string array to try other possibilities. I think these were difficult for me. Let's continue recursion with Grok AI. It will teach us all the basics and will iteratively ask us if we got it or not. So I had given it the prompt for teaching me recursion, and it returned with what is recursion. Recursion is a method where a function calls itself to solve smaller instances of same problem, breaking it down until it hits a base case. ठीक है, I got it. So I returned recursion means a function calling itself. Okay, that's on spot. Great job explaining it. You've nailed it. So dry running recursion. To understand how recursion works under the hood, we try dry run it by tracing the call stack, a structure in memory that tracks function call. So we will use Calibra to visualize the recursion. Why am I sitting in this? So should I get into full screen? Okay, let's let this. So it will help us. It is asking in one sentence, explain dry running back to me, or say I got it to proceed. So what is dry running? To understand how recursion works, we dry run by tracing the call stack, last in, first out structure in memory that tracks function calls. So so in the stack, factorial 3 will get stored and then we will compute 3 into factorial of 2. And it will store factorial of 2 in the stack and then compute 2 into factorial of 1, then it will store factorial of 1 and return 1, which will return 2 into 1, which will pop factorial of 1. Okay, I got it. Let's move to the next concept. So common recursion patterns are, this is the basic form solved by reducing the problem size. Example n to n minus 1 we combining result. Example factorial Fibonacci sum of digits. Okay, ASCII for Fibonacci of 3. What is simple recursion? Simple recursion is reducing the problem into smaller problems directly, like n to n minus 1, and for example equal factorial Fibonacci and and sum of digits. So that's a solid explanation. Yes, it's all about direct reduction to smaller sub-problems. Tail versus not non-tail recursion in that we also had read about. The recursive call isn't the last operation. There's work after it returns. Example factorial. Multiply after factorial of n minus 1. Avoid stack overflow for deep recursion. Okay, convert non-tail to tail. Use accumulator. Okay, I got it. Include exclude pattern. These are for subsequences that we were doing right now. So this is backtracking pattern for generating subsets or combination. At each step, decide to include or exclude the current element, recurse on the remaining, and explore all possibilities. Used for power set subsequences for a string ABC, include exclude each character to generate all 2 to the power n subsets. Key no state restoration needed if you build the result incrementally, pass by value or append remove. Okay, I want to understand it further. So it is used for finding the subset or subsequences in a string or array. Hmm. So I get confused on backtracking. So it's a decision tree approach in backtracking. For each element in the input array or string, you branch into two choices, included in the current subset path or excluded, and recurse on the rest. Okay, it is like a decision tree. Theta. This explores all 2 to the power n combination exhaustively. Each element has two choices, but you can add pre-running. That is early stuff for efficiency. Like if some exceeds target, okay. Mm, subset sum, find if subset sums to k equals to 3, from 1 to 3. What makes it? Mm, okay, I'm getting it that we recursively check for all the possible combination of the elements by recursively choosing two options to include or exclude the current element. Let's say mm, we have a string A, comma B and C, sorry, ABC, and we want to generate the subsequences of ABC. So the first subsequence will be a empty string Mhm. And the second subsequence will be quadratic scalar. Okay, so I need to explain in one sentence what this pattern is useful for. This pattern is useful for generating subsequences of string or combination of arrays elements. That's a great point. Yes, it's perfect for exhaustive generation like subset combination or subsequences. Decision recursion pattern. But I need to learn this. Let's go here and teach you recursion with backtracking on the pattern of subsequences and combinations. Combination. Stupid AI. That fast. I got it. Forget this AI will not fine. That will be work and solve problem. Discipline. Passive implementation of weekly. Okay, we are already solved. Okay. If the given number mm, which we need to raise the base is negative, what we will do then? N is negative. सो पांचवे टेस्ट केस फेल हो गया। नाइन प्लस रन टाइम है। Why is it giving runtime errors? We are calling x comma n minus 1. That means from this that is asked. Okay, x to the power 0 is 1, x to the power 1 is 1. That is correct. Handle negative powers. It's also done correctly. Recursive step for positive powers is safe. Okay, using can cause integer overflow because it's still negative. क्या कह रहा है? सही है फिर भी सही नहीं है। ओके, स्टैक ओवरफ्लो हो सकता है, वो ठीक है। बट व्हाट इज द प्रॉब्लम विद दिस field? पोटेंशियल इशू क्या है? इंटीजर ओवरफ्लो हो सकता है, नेगेटिव केस यूजेस which works but is slightly less efficient than the standard fast exponentiation. अरे यार, this was better. ठीक है। Integer dot ओके, ये चीज इम्प्रूव हो सकती थी। इसको एक मिनट, if n is less than 0, we can return now the power of x comma minus n. 1 upon, okay, 1 upon, yeah, return 1 upon power of x minus n. Okay, simply just turn it into that, and here the problem is with stack overflow. इसका क्या अप्रोच है ऑप्टिमाइजेशन वाला? डबल हाफ फिजिकल स्ट्रीम माय पावर एक्स। ओके, हाफ इंटू हाफ करनी है बस। अच्छा ठीक है, बस आगे तक जाना है। ओके ठीक है, ये तो हो गया। डबल हाफ इज इक्वल्स टू माय पावर ऑफ एक्स कॉमा एन बाय टू एंड get now and if n is even number, that means n factorial of 2 is equals to 0, we will return half into half. Otherwise, we will return half into half into x. Now let's submit. Still getting the same error, but after why? Now the error is with this negative for the part. Okay, minus long of time to avoid overflow. So here we just have to add long. Still, I think it will give runtime error. Is the compile time error से आ गया। Use conversion ये क्या बता रहा है इस लेक्चर में? Finally एक प्रॉब्लम सॉल्व हुआ। एक द कंप्लीट लॉजिक जो मेरे भेजे में गया लीड कोड का। It is 28. We got more hidden problems to solve. Let us now count good numbers. What is the problem? A digit string is good if the digits zero index at even indices are even and digits at odd indices are prime. Prime number वाला भी लगाना पड़ेगा. For example, 2582 is a good because the digit 28 at even positions are even and the digits 52 at odd positions are prime. However, 3245 is not good because 3 is at even index but is not even. So given an integer n, return the total number of good digits string of length n. So we have to compare all the combinations. My mind will get, or it says that it is a easy problem. Let's get subsequence pattern. What we had done was very different from this problem. Mm, In this problem, we have to return the list of lists. Tomorrow, I have my assessment. Okay. Let's try to convert this solution into the lead code problems solution. We need to generate all the possible subsets without repeating subset. So the solution set must not contain duplicate subsets within the solution in any order. Let's create a result list. So list and teacher and result list to my array and if nouns equals to the result. And then we will create another function method to generate the subsets. So GENERATE subsets, and we will give it index 0 and 0 as input, none array and new array list and also result. So the new array list will be our current array, and then we will result. So we need to create this method private void generate subsets, and input will be int index, int array nums, and list integer current subset, comma list list integer result. And we'll check if index is equals to nums dot length. If it is, then you will add result dot add new array list that that. Okay. So we are just adding the copy of the current subset, and then we will return. And the decision one will be generate subsets. Mm, skipping the skipping the first element, right? So index plus one nums and current subset and result. And the next step, the details of current subset dot add nums of index will be added, and then we will update generate subsets of index plus one comma nums comma current subset comma result. और बैक ट्रैकिंग के लिए क्या करना रहता है, लास्ट वाला एलिमेंट रिमूव करना रहता है, और मैं भूल गया कैसे करते हैं बैक ट्रैक. हम्म, जिसमें अभी ऐड किया करंट सबसेट है वहीं से लास्ट वाला छोड़ देंगे करंट सबसेट डॉट साइज -1। ये सेम ही है ना, लाइक यही इम्प्लीमेंट किया था हमने। अब इसमें हमने रिजल्ट को लिस्ट इंटीजर में स्टोर कर दिया। सो आई थिंक लेट्स सी, रन करके देखते हैं, एरर आएगा तो पता चल ही जाएगा। आ गया एरर। क्या गड़बड़ की है? कंपाइल टाइम एरर है, स्पेलिंग मिस्टेक, करंट सबसेट सेमीकोलन नहीं लगाया, सेमीकोलन की जगह कॉलन लग गया। That is one again. फिर से एरर, करंट का सी कैपिटल कर दिया। क्या गड़बड़ कर रहा है यार मैं? आज कोई लाइव चैट में मैसेज नहीं कर रहा है यार, व्हाट इज द प्रॉब्लम? चलो चल गया ये तो। आज ऐसा क्या है भाई, आज कोई मैसेज क्यों नहीं कर रहा है लाइव चैट में? कोई देख रहा है क्या? Hey, is anyone watching? हाँ, कॉन्करेंट व्यूअर्स में तो 3 लोग दिखाई दे रहे हैं। मम्मी पापा ही तो नहीं दिख रहे मैंने। देख के आता हूँ। Baki, if you have any doubt, you can ask, like any query to any type things. Want to know anything? Who am I? Where am I from? Who are these 3 people constantly watching on screens but not interacting with me? Okay, we have done this power set wala problem, and learn all patterns of subsequences. Guys, you should interact with possible subsequences using bit manipulation. How is it possible? Bit manipulation से देखते हैं। All possible substrings and array list string answer is equals to new array list. Okay, strings are equals to recursion and backtracking. It is not that difficult backtracking, but खुद से सॉल्यूशन सोच रहे ना, हालत खराब हो जाती है। कल किसी का कम्युनिकेशन राउंड है क्या? कैप्ची में? whoever is watching. Hmm. We have done 152 problems so far. आज ऐसा क्या है कि आज एक भी लाइव चैट पे मैसेज नहीं आ रहा है? एक भी मैसेज नहीं है। पानी तो क्या होता है? Can you discuss further problems? तुम लोग कुछ बोलते ही नहीं हो यार। बस चुपचाप बैठे तो सब देखते बैठे हो। आज किसी ने कमेंट दिया था, भाई पहले तू अपने कॉन्सेप्ट क्लियर कर ले, उसके बाद पढ़ाना। तो अगर भाई तुम देख रहे हो तो मैंने तो ये कभी कहा ही नहीं कि मैं पढ़ाने आता हूँ। अब पानी की बोतल लेकर आता हूँ, तुम लोग देखो बस चुपचाप बैठे बैठे। Okay, let's solve the next problem. No one is speaking up in the live chat. You guys are very, very shy. Let's solve this. Generate all parentheses. So given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. What does it mean by well-formed parentheses? Let's create a list of strings named result and uh, आज क्या मेरे कमेंट सेक्शन पे जान लगा कमेंट ही नहीं सकते तो When an array of distinct integers candidates and a target integer target return a list of organic combinations of combinations where the chosen number sum to target. So you may return a combination in order. I tell you update on let's check it out. Here, hold on. Stupid AI. think जिसने जरूरत हो भेजा नहीं किया थैंक यू अब लिटरली कोई भी कमेंट नहीं करता ऐसा कैसे हो सकता है लिटरली एक बंदा भी नहीं था गाइस कमेंट सेक्शन हैंग हो गया क्या लाइव चैट में कोई भी मैसेज क्यों नहीं कर रहा है आज I am handling election here. What's it for today? And tomorrow I am having my assessment, so I need to prepare for it. So this was it for today. I am ending the live stream. अरे वंशवर्धन is back. चलो फाइनली कोई तो आया। अब मैं थोड़ा आधे घंटे तक और सरवाइव कर लूंगा। मैं अब बहुत देर से बैठा हुआ हूँ यार। वर्धन जी, कैसे हो आप अब? क्या सीन है हैदराबाद में? कैन यू इमेजिन वंशा, मतलब आज स्ट्रीम को 3 घंटे हो गए और किसी ने एक भी मैसेज नहीं किया। कॉम्बिनेशन सम प्रॉब्लम कर रहा हूँ मैं, बैक ट्रैकिंग वगैरह, रिकर्शन वाले प्रॉब्लम्स प्रैक्टिस कर रहा था ताकि से बन जाए। अभी मैंने ऑलमोस्ट 50% रिकर्शन के पैटर्न्स वाले प्रॉब्लम कर लिए, लाइक जहाँ तक प्रॉब्लम नंबर 20 तक इस टाइप के कुछ प्रॉब्लम्स कर लिया। बट बाकी के प्रॉब्लम्स हो नहीं रहे मुझसे अच्छे से। तो मैं सोच रहा हूँ थोड़ा टाइम दूंगा, और कल मेरा असेसमेंट है तो अब मैं सोच रहा हूँ कि जल्दी सो जाऊंगा आज। You have solved combination sum. That's great. I am feeling exhausted today. और पता नहीं यार आज क्या सीन हुआ है, लाइक लिटरली नो वन वाज कमेंटिंग। मतलब स्ट्रीम की रीच अच्छी जा रही है, लोग आ रहे हैं, लोग देख रहे हैं, लोग सब्सक्राइब कर रहे हैं, बट नो वन इज कमेंटिंग। मतलब किसी ने अभी एक भी मैसेज नहीं किया था। ओके, लेट्स सॉल्व द प्रॉब्लम्स नाउ। यस, सब्सीक्वेंस वाला प्रॉब्लम हुआ। सब्सीक्वेंस एंड पावर सेट वाला प्रॉब्लम कर दिया। Like, ये रहा वो जो प्रॉब्लम्स जो मैंने किए हैं आज। आज मैंने ये सारे प्रॉब्लम्स किए, 7 प्रॉब्लम्स किए। लीनियर सर्च किया रिकर्शन से, बाइनरी सर्च किया रिकर्शन से, फिर चेक पैलिंड्रोम किया रिकर्शन से, रिवर्स स्ट्रिंग किया, फिर जनरेट सबसीक्वेंस वाला प्रॉब्लम ये रहा जो आज ही किया मैंने। और ये डायरेक्ट वीएस कोड पे किया वो शीट देख के। और उसके बाद में पावर सेट किया, और उसके बाद में काउंट काउंट सब सीक्वेंस वाला था, सबसेट विद सम। और स्ट्रिंग परम्यूटेशन पे आके मैं अटक गया, मेरा दिमाग ही नहीं चल रहा है स्ट्रिंग परम्यूटेशन पे। तो सेम टू सेम है कॉम्बिनेशनल। अच्छा ठीक है, ट्राई करते हैं। तो ये वाली लिस्ट में था क्या वो कॉम्बिनेशन सम एंड क्वींस इसमें नहीं था वो। ये रहा। इसका प्रॉब्लम स्टेटमेंट ही थोड़ा मेरे को ऐसा डरावना लग रहा है। Given an array of distinct integer candidates and a target. Okay, एक integer given है हमें, array of distinct integers given है candidates. So array consists of candidates and a target integer target. Return a list of all unique combinations of candidates where the chosen number sums to target. ओके, मतलब ये एरे का सबसेट रिटर्न करना है जहाँ पे सम इक्वल्स टू टारगेट हो. ओके, द सेम नंबर may be chosen from candidates an unlimited number of times. That can be from the calculation. Okay, let me try. ये वाला प्रॉब्लम सॉल्व करके भी ट्राई फाइंड करेंगे. मेरे साथ भी कुछ ऐसा ही हो रहा है आज. प्रॉब्लम्स को देखते ही नींद आ रहा है. So we have an array candidates. So power subset. Okay, let's create a form. Answer. So what we can do, list of list integers, result or answer whatever is equals to array of list. And create one so method. What looks static for final combination and index on array. Let's call it candidates. And target and result. Given array, okay, let me index. We need to return the list of all human combinations. Mm, okay, it will get all this feature, answer, not answer, sorry, and current combination के लिए क्या होगा एक और error list list teacher combination current combination compare 10 lakhs is equal to candidates practice length that means it closest to the end of the parent of 2 half the joy of have ये कौन सा प्रॉब्लम है ये है प्रॉब्लम रिकर्शन का स्टेप नंबर 7 से कॉम्बिनेशन सम मीडिया स्टेप नंबर 7 लेक्चर नंबर 2 combination sum हेलो ब्रो। मुझे भी बहुत डिफिकल्ट लगता था एरेस इनिशियली। आई हैड सर्वाइव्ड इट, आई डोंट नो हाउ। और रिकर्शन मुझसे नहीं बन रहा है। आई एम जस्ट ट्राइंग। सी लाइक आई थॉट कि मैं एक या दो दिन में रिकर्शन खत्म कर दूंगा, लेकिन प्रॉब्लम्स ही नहीं हिल रहा है मेरे से। जीनियस तो नहीं है यार। एरे वाले हार्ड प्रॉब्लम्स थे थोड़े। मैं अवॉइड कर रहा हूँ ये प्रॉब्लम सॉल्व करने को, मेरे को नहीं आ रहा समझ ये कैसे चेक करूँ मैं कि डुप्लीकेट्स भी नहीं हो उसमें। मुझे फिबोनाची जो लीनियर वाले रिकर्शन के प्रॉब्लम्स है वो तो मुझे समझ आ गया, लेकिन ये वाले जो बैक ट्रैकिंग वाले प्रॉब्लम्स है वो समझ नहीं आ रहे हैं मुझे। मैंने ये इतने सारे बेसिक बेसिक वाले प्रॉब्लम किए हैं अभी, ताकि मैं ये स्ट्राइवर की शीट के प्रॉब्लम सॉल्व कर सकूं। लेकिन स्ट्राइवर की शीट के प्रॉब्लम्स मिलते ही नहीं है ज्यादा ऐसे। जावा से कर रहा हूँ मैं, फेमस बेसिस प्रो। Let's see. Okay, it can now be calculated because the function has index target and combination, current combination. Initially, the index will be zero, target is given in the data structure. Okay, data structure है ये. List will be empty. Now there are two options: ways to pick or not to pick the current index element. If you pick the element again, come back at the same index as multiple occurrences of the same element is possible. So the target reduces to target minus array of index. If we pick the element again, come back at the same index as multiple occurrences is possible. So the target reduces to target minus. Could you design arbitrate the current element, move on to the next index and traffic reduce stays as it is. Keep on repeating this process for the indexes like the size of the variable for a particular recursion, or you can also stop the recursion when traffic will be zero, but tries to generalize working without automating conclusions. Given an array of distinct integer candidates, okay, this much is well known. The core idea is to pick or don't pick strategy for every element in the candidates array. We have two choices: pick the element, add the current element to our temporary combination list. Since we can reuse elements, we make a recursive call for the same index but with the target. Mm, Given an array of distinct integer candidates in the topic integer target, you need to find all even combinations of candidates where the chosen number sums up to target. So, okay, you can use the same number from candidates multiple times. So, 2, 3, 6, 7. So, target is 7. Mm, So, let's say if we pick 2, try run this the let's post the execution with candidates equals to 2 comma 3 and target equals to 7. Mm, So index is 0, target is 7, current combination is empty. Start at index 0, value is 2, target is 7, pick 2, call अच्छा ठीक है sum minus current value that is 5 and current value inside is 2 and it okay we can check multiple times. We can take the same number multiple times, so it will start again from the same point and invalid path. So ठीक है -1 तो exist ही नहीं करता पूरा उस array में तो it will become valid. So we will have to backtrack. So we will go on to pick don't pick 2. And if you don't pick 2, it will result in अच्छा ठीक है एक ही step backtrack करेंगे and check. ये काउंट सबसीक्वेंसेस जैसा कैसे है इतनी तगड़ी बैकट्रैकिंग तो नहीं है उसमें मैंने क्या किया था काउंट सबसेट विद सम इसमें इंक्लूड एक्सक्लूड वाला बटन था it keeps checking by picking up the same number until the target becomes less than 0. So if index is array dot length, it will check if array target is equals to 0. And if the target becomes 0, it will add a new array list current combination to the answer and then return to vector. Pick current element if array index is less than or equals to target. Add the element to a current path. Dot add and recurse for the same index with the reduced target. Okay, with recursing for the same index with the reduced target. Okay, so this is the backtracking step. It is not backtracking, it is reducing the target. And backtrack, remove the element to explore other paths. Current combination dot remove, current combination dot size minus one. Okay. If we found the valid combination, then only we will return. Otherwise, we will backtrack. And we will find this. Let's try. रिजल्ट डॉट एड एरे लिस्ट कॉम इतना बात तो ठीक है यहाँ पे if target is equals to 0 return statement इसके बाहर okay. क्या आवाज इतनी क्लियरली आ जाती है हाँ, माता श्री ने कहा है जब भी सोने का तो सोने का ओके me revising the things मेरे तो थोड़े सबके ऊपर से जाते हैं मैं कैच नहीं कर पा रहा हूँ अभी candidates on index is less than equals to target, then we will add to current combination dot add candidates at index. ठीक है अभी इसको सिलेक्ट कर लिया and we will reduce the target and apply find combination again. So find combination with the same index, right? Index को index ही रहने दो. Index, comma, candidates. Candidates भी same है. Then target will get reduced by the current element. So candidates of index at the index. Okay. And comma result, comma combination. ओके तो बात सही समझ आ रहा है और बैक ट्रैक करने के लिए अगर वो वैल्यू सही नहीं होगी तो बैक ट्रैक करके कहाँ जाएगा कॉम्बिनेशन डॉट रिमूव combination dot size -1. Okay. And if it skips the current element, it will continue with the next index. Combination index +1, comma, candidates, comma, target, comma, result, comma, combination. एंड नेक्स्ट कॉम्बिनेशन में भी यही चीज रिपीट हो जाएगी. अरे चॉइस पे नॉट पिक पिक नॉट पिक यही सब दिया था ना इसके अंदर. कहाँ गया कहाँ पड़ रहा था. इंडेक्स ऑन टारगेट आंसर करंट कॉम्बिनेशन बैक ट्रैकिंग. इसके बाद कुछ रिटर्न करना. अब इसको इम्प्लीमेंट कैसे करेंगे मेथड को. जीरो कैंडिडेट टारगेट एंड वी विल रिटर्न द रिजल्ट. रिजल्ट क्रिएटेड अपना. You have to do this and return answer. Let's say find combination of zero index and candidates, comma target, comma reserve, comma combination के लिए क्या empty array list कैसे देंगे. New array list. New array list. Okay. ये लास्ट प्रॉब्लम है आज का. फिर मैं बंद कर दूंगा इसको. मिसिंग रिटर्न स्टेटमेंट. अच्छा आंसर को रिटर्न भी तो करना. चल गया चल गया चल गया ठीक कारण चल गया. लेकिन पूरा सॉल्यूशन तो मैंने जेमिनी से देख लिया. वैसे ये वाला प्रॉब्लम अब मैं कल खुद से करूंगा कॉम्बिनेशन सम वाला. बट अभी के लिए ठीक है. या बाकी प्रॉब्लम्स कैसे. ओके वंशा आर यू देयर. आई थिंक आई शुड एंड द स्ट्रीम नाउ. कल जल्दी उठना है मुझे. I need to wake up early tomorrow. Okay, see you tomorrow, and I hope you are doing well. वमसा बाकी और कोई प्रॉब्लम तो नहीं हुई ना. You are doing development for SIH. That's great. All the best for your SIH. We'll see you tomorrow. Okay. We got prototype is so complex. अच्छा तुम्हारे प्रोजेक्ट का प्रोटोटाइप या फिर जनरली प्रोटोटाइप्स कॉम्प्लेक्स होते हैं. प्रोटोटाइप तो बहुत इजी होता है. I'm good, all things fine. See you tomorrow. Okay, your solution has so many features. That's good thing, bro. Good solutions are complex. No one is born big, right? You will become a big developer. Okay, so we'll see you tomorrow, Vamsa. And don't worry, keep putting the hard work, you will get results. And all the best, all the very best. Okay, bye bye. I'm ending the stream, guys. See you tomorrow. We'll restart recursion from the basics. Okay, bye bye. Good night, everyone.